Hello, my name is Jacob Buell. This is Lab 1 about charged tape for Physics 2212. So as an introduction, the aim of this lab experiment is to use pieces of tape to determine the exchange of electrons between different surfaces so we can calculate an estimate of the number and the charge of the electrons that are transferred. And so to do this, Newton's second law and Coulomb's law will be utilized to calculate the charge on each piece of tape. So, Newton's second law. Newton's second law of motion states that the net force is the change in momentum over time. So this law can be written as F net equals ma, or F net equals the change in momentum dp over dt. And Coulomb's law. So when two electrically charged particles come near each other, they exert a force on one another. And this is described in Coulomb's law, which is also known as the electrostatic force. And so in Coulomb's law, K is also the Coulomb's constant, which is 1 over 4 pi epsilon naught. So as an outline for the lab, in this lab, I conducted an experiment with two pieces of tape, where I created an electrically charged piece of tape and determined its charge by bringing my hand near to it. And so I also created a glow script model of these tapes as point charges to estimate the charge on each tape necessary to float one tape above the other. And then I also created another glow script model which represented the charged tapes as a line of charges to estimate the amount of charge on each tape necessary to float one above another. So for the experiment, in the photo you can see a base tape and a U-tape. So in the system is the U-tape and the surroundings are everything else. So about the experiment, I used two tapes equal in length, with the one tape taped down to my desk, which is the base tape, and the U-tape was ripped off quickly and was charged. And then I hung it next to different objects to determine its charge. And lastly, the U-tape was placed beside another similarly charged U-tape until it floated and the distance was measured to calculate the charge. So in this photo you can see bringing a hand near it and it attracting to the hand. So the U-tape was attracted to my hand that I observed, but it was repelled by another piece of U-tape, but it was also attracted to a neutral piece of wood. So in conclusion, for this part of the experiment, the U-tape must be positively charged. Now to determine the actual charge, discover the tape mass to be 0.00015 kilograms, the length to be 0.2 meters, and the width to be 0.019 meters. And the distance d, which is important for the force calculations, between the two tapes is 0.02 when they are levitating. Now, the force of gravity can be calculated from mass times the gravitational acceleration constant near to Earth, which comes out to be 0.00147 newtons. So the tape charge, we know that it will be in equilibrium because it's stationary floating above the other tape, and so the electric force is equal to the force of gravity. And then setting these equal to each other, we can solve for Q, which comes out to being the square root of mg 4 pi epsilon naught times the distance squared. And all that under square root, and then that comes out to 8.08 times 10 to the negative 9 coulombs. And so the area of the tape we can calculate, and so can we get the area of the atom, which comes out to the number of atoms of tape being 3.8 times 10 to the 17, which means 1 electron for every 7,600,000 atoms, with 5.05 times 10 to the 10 electrons lost. So the first glow script model has a very similar results to the calculations because it is a point charge model for the two pieces of tape. And then the second glow script model has a little different results because the charge is distributed out through the entire surface of the tape. So you can see the two pieces of tape and the force of gravity and the electric force being represented by the blue and yellow arrows. So in conclusion, to answer the what if question, if the signs of the electrons and protons were switched, the result would still be the same, and this is because they are still opposite charges and repel like normal. You just lose protons instead of electrons. And for the why question, Value of Q from the two different models are different because the charge is evenly distributed in the line model versus the point charge model.